Okay, guys, let's finish. I want us to finish this now. Okay. We are finishing this in the remaining 8 minutes. Now that we have this, which is, by the way, an exercise, we could even finish it now. You go and you do the exercise if you so wish. So let's just demonstrate. Now, all I'm going to do is to demonstrate the theorem we have had on this example here. We are going to demonstrate it on this one here. And we see how we get this answer. The remaining 8 minutes are more than enough for us. Okay, so in the simplicity, we are going to simply apply what we have just discussed here. So I am applying this. So remember, we already have. So what we have is what? What you call GT. What is GT? Just look at these two. Compare this with this. So I'm going to simply look at the left-hand side. I'm going to compare these two here. Let's compare just these two. If you look at a comparison of those two, in simple, we are remaining with 7 minutes. If you look at the comparison of these two, we have our G. This is GT. The GT, this GT here is basically equal to t squared plus 1. So this is t squared plus 1. That is the GT we have. This GT. So we have this term here, which is equivalent to that term there. Then we have t minus 1. This is t minus a. So what do we have as a? This one simply tells us that the a here is actually a 1. So our a is a 1. So here we have a, which is equal to a 1. Now, how do we use this? We are told that if you have this GT here is equivalent to that term there. So now we have to redefine this. So we already have a is 1. So if it is a which is equal to 1, so what do we have? We have e of minus s. Guys, there is a small mistake here. In here we have L, which is not there. Please include it. There is a certain L here, L for Laplace. I needed to probably reduce. I may have to. Let me reduce my thickness to something like this so that this fits in well. Clear that. Erase. Right. Then I get back here. So we have a certain L here. There is a letter L there. So it is E minus S, then the Laplace of that balance. I'm hoping we are clear now. So what we have is, I go back and I maintain my, where are you? Right here. And I was right there. Okay. So this is e to the minus s. Remember the a is 1. So I have now L. This is the Laplace of G. Then this is t plus a. Okay, that is what I have. I hope we are together. So since this is G of t plus a, but remember now, this was t, but this is t plus a. So I need to replace this t with t plus a. But remember, a is 1. So since a is 1, I can now remove the a here, and I replace it with and I replace it with a 1. So it is gt plus a, but the a is 1. So I replace it with 1 here. So, but remember, this is gt now. These are like dealing with the functions. This is your calculus 1. Since this is gt, which is t squared plus 1, but now we have gt plus 1, implying that now the blue will become, it will become g. Remember, this is now t plus 1. It's like dealing with the composite functions. So my t is now t plus 1. This whole thing is squared. Then I add that 1, which is now plus 1. I hope I'm clear there. If that is the case, when you expand this, what will this one give you? Expanding this, it is going to give you g of t plus 1. If you expand that thing, it will give you gt plus 1, which is equal to exactly t squared. This will give you t squared. This is plus 2t. Hopefully we are together. And that is plus 2. This is plus 2. That is what we have. So now it means that where you have e minus s, this minus s, L of gt plus 1, remember it was t plus a, but a was 1. I can now rewrite this and I express it as that one now becomes this whole thing here in red now. It will become e, this is minus s, and I am computing the Laplace of what? Instead of gt plus 1, we have just seen that when you expand this, it gives you t squared. This is t squared plus 2t. And this is plus 1. This is plus 1. Is that okay? And now from this, you use the powers of t. The good thing with the powers of t, we said if you have the Laplace of t to the n, this is L, the Laplace of t to the n, guys. We said this one is the same as n factorial over s of n plus 1. Is that okay? So now the answer comes out directly. This one was e to the minus sa, but remember our a is 1, that is the e minus s. Now we have t squared. So it means that n is 2. Simply throw a 2 here. 2 factorial is 2. So if it is 2, then that is s cubed. That one, this t squared gives you this first term here. I hope we are together. The t squared is the 2 over s squared. If you substitute here, then you have 2t, t is to the power 1. That is 1 factorial, which is 1, s squared. But remember, there is a 2 out here. There is this 2 here. So when you throw the 2 out, you have t to the power 1. According to the Laplace of powers of t, that would give us a 1 over s squared. With this 2, then you end up with the 2 over s squared. And then lastly, here you have 1. But what is 1? 1 is t to the power 0. So since it is 2 to the power 0, 0 factorial is 1. This one will basically give you 1 over s if you are dealing with a 0 here. So it is 1 over s, but remember, the 1 over s we are having here. Oh, sorry, I made a mistake. This is a 2. When you expand this, you get 2. This is not 1, but rather 2. Let's just clear that a little bit. This is a 2. not a 1. This is 2. So since it is a 2, you factor out that 2, you remain with 1. So the 1 here is equivalent to t to the 0, which is 1 over s. So the 1 over s times 2, that is the 2 over s. And that marks the end of today's lecture. Unless there are questions, those who have lectures at 11, you can log out and you go for your lectures. If there are questions in the chat, you can attend to them. Let me see. It's a +2. This is Alex Batesaki. Thank you very much. I noticed that at the end. Thanks. It was a 2. Yes, I've noticed that. I think the rest, you are all good. No issues. Isn't it +2? Indeed, it is 2. Some Laplace sign missing on G. Yes, I think I have also indicated that. This is Madame over Sami. Nansami, the Laplace, I have included it there. That was the L into G plus. Okay, guys, I think that is indeed what we have covered today. So we leave it at that for today. We'll just pick it up next week. I see something in the chat. Is the WhatsApp? Is the WhatsApp group? I don't know what is this now. I've not understood the message. Right. So when we meet next week, we will deal with the remaining part now. And next week we will now have to start with this, and then we run a demonstration of this, and then we engage gears. Okay, we do an example there. Gamma functions, these ones I will not waste time. You've overly done this in the probability theory, and you've overly done this in elements of probability and statistics. I will not waste time there. From gamma functions, rules of operations. So what we are going to do when we meet on, is it Monday? I think we are meeting on Monday at probably 11, I think. So when we meet on Monday at 11, we will pick it up from this one I have finished. We'll start from here. And then we'll go all the way. Gamma, you have already done that. I'm not going to waste time with that. Then we'll go to Laplace operation rules. Okay. I think there is nothing. Okay, for the recorded, I'm going, as I've said, that the recordings, I have them, guys. They are big. If you are within the neighborhood of campus and you can share them on your different WhatsApp groups, I can liaise with the coordinators to come and pick those links, rather the recordings, and then you go through them on your laptops or your gadgets. Okay, I think we can end the lecture now. Have a blessed day, and we meet on Monday at 11 a.m. Monday, 11 a.m. All of the best.